In this video, we're going to discuss vector addition, and we're going to discuss two ways of adding vectors. One's an approximate way, the graphical method, and the another is more mathematical, more reliable, precise, the analytical method of adding vector components and then reconstructing the final vector. So in this graphical addition system, here's vector A, here's vector B. Vector A, 160 degrees from the x-axis. The positive x-axis is 0 degrees, and angles are positive counterclockwise. So angles are positive clockwise from the positive x-axis. So 160 degrees, and the vector has a length of 4 meters, a magnitude of 4 meters. Vector B is 6 meters. 75 degrees from the x-axis. Again, this is 0 degrees on the x-axis. And we want to add those two. We do so by taking either of the vectors as the first vector and draw it. And then we're going to take the second vector, kind of lift it up, and draw it where the first vector ended. So we sketch either A or B. I'm choosing to sketch A, so I first drew on vector A, and then I drew on vector B. Vector B, if I attempt to put it on here, here's where it was originally, 75 degrees from the x-axis. So I take this vector in my mind, I pick it up, and I start drawing it at the end of vector A, and if I draw a line here parallel to the x-axis, I maintain the orientation of vector B, 75 degrees from this line that's parallel to the x-axis. I end up at this point, so there's our A plus B, and the result vector, vector C, I start by drawing at the origin. I end where the second vector ended, and that's vector C. So we're predicting here a vector that has an angle beyond 90 degrees. That's our prediction, and it's longer than 6. You can see that from the diagram. But the graphical method, that just gives us an approximation of what the vector result is. So let's go for the analytic method, the mathematical method of adding vectors. And we're going to make use of components, vector components, and we have a ability to do this because either you draw the right triangle and complete it, or you just go ahead and calculate the components using the full angle that's given and sine and cosine. The sine function is associated with the y component, and the cosine function is associated with the x component. So that will give us ax, ay, bx, by. Then we're going to add the x components together and find the x component of the result vector. We'll add the y components together and get the y component of the result vector. Then we'll use Pythagorean Theorem to give us the magnitude, and I forgot to put on square root here. So this is Pythagorean Theorem, where cx and cy will be the two short sides of a right triangle. C is the hypotenuse. And we'll find the angle for the triangle using inverse tangent. We may have to adjust this by 180 degrees because the inverse tangent only returns angles between minus 90 and plus 90. So let's start here with the A vector. And the x component is delivered to us by the cosine function. We take the magnitude of the vector, and I'm not going to put the units on here, but it's 4 meters, and then cosine of 160 degrees. I'm choosing not to find the 20 degree angle in here and work that right triangle and then manually attach a minus sign to that. We can use the full angle measured from the positive x-axis in a counterclockwise direction, and this will give us automatically the correct plus or minus sign. So do this with your calculator. I came up with minus 3.759 meters. And AY, that is 4 times the sine of 160 degrees. Do you expect this to be positive or negative? you expect positive. We're up above the x-axis, and that's what it turns out to be, plus 1.368 meters. For bx, we just use the numbers for b, 6, and cosine of 75 degrees. And this produces, if I can find it on my worksheet here, 1.553 meters. And b sub y is 5.796 meters. So there's our ax, bx, ay, by. And now cx. For cx, we're going to combine the ax minus 3.759 and the bx plus 1.553, and we end up still negative, minus 2.206. But I've added the negative value of a sub x and the positive value of b sub x. C sub y, we're going to add the two y components together. Both of those are positive, and we end up with 7.164. So I have my two short sides of the right triangle for vector C, and I'm going to make a little bit of a sketch here. This may not be to scale, but C sub x minus 2.2, let's say we go to there, and C sub y, 7, let's go up there. So the side I have here is 2.206, and it's a negative, and C sub y is 7.164. And our result vector would be right here. So to find the magnitude of the vector, we use Pythagorean Theorem, of course. A squared plus b squared equals c squared. So we have the sides here, minus 2.206, we'll square that. And 7.164, we'll square that. So I get 56, you should check these numbers on your calculator, 56.189 equals c squared. Take a square root of both sides, and I come up with 7.50 meters for C. Now, what about the angle? What's the angle? And this is the angle I'm searching for. From the positive x-axis, again, is 0 degrees. And to do this, I'm going to do inverse tangent. Inverse tangent will give us the theta value. Maybe I should write out tangent for you first. So we can either work inside the right triangle or outside, but tangent of theta will be 7.164 and minus 2.206. So I'm kind of searching here for this angle. I'm going to call it phi, actually. So opposite divided by adjacent. Opposite divided by adjacent. It is important you keep the plus and minus signs attached here. So we take inverse tangent, of course, of both sides. And I need inverse tangent of minus 2.206. That will give me the theta value. And when you do that with your calculator, you'll find you get minus 72.9 degrees. Minus 72.9 degrees. Well, this does not look like minus 72.9 degrees. Where is this? It's actually the extension of the vector C into the fourth quadrant. So minus 72.9 degrees. And what I have to do is add 180 degrees to that. The inverse tangent gives us a result in the wrong quadrant, so I add 180 degrees, and I get that theta is 107.1 degrees, which is expected based on our graphical addition. So we get a length of the vector, a magnitude of 7.5, and an angle for the vector measured from the positive x-axis, 107.1 degrees. And that's where we will end this discussion of the vector addition graphically and analytically. If you want some more physics videos that could help you with concepts and example problems, check out physics.gpclements.com for a list of those. Nothing's for sale at this site. There's no registration required. Keep working, practice problems.